Hi everyone, we are discussing about some basic principle of organic chemistry unit 12. Today we are going to discuss first about 3D presentation of organic molecule. 3D presentation. Generally, compound like water, carbon dioxide, etc. In these cases, we generally depict them or represent them in two-dimensional axis. As for example, here you can see this is x direction, this is y direction, so we can represent the molecule in these two axes. So let us take, this is water molecule. Here all three atoms of water molecule can be represented in this two dimensional plane. Okay, this is the plane of the computer or paper, whatever. Now if we take compound like, suppose methane, here the geometry is tetrahedral, so and the structure is like this. Okay, so here what happened, these three position, these three atom, hydrogen, carbon, this carbon and this hydrogen, these are in the plane. Okay, these are plane in the paper. Now this molecule, sorry, this atom and this hydrogen atom, these two are, one is above the plane and another is the below of the plane. So to represent this molecule we need 3D form. I mean, three axes are needed to represent the structure of this compound. So here if we draw, so it will be x, y and z. So these three axes are needed to represent the position of this molecule. Here this solid line, it is known as solid wedge. Okay, it is above the plane. I mean, if the hydrogen, carbon and hydrogen, these are in the plane of the paper, then this bond is solid wedge. I mean, it is above the plane or towards you, and this dash line called as dash wedge, this is below the plane of the molecule. Okay. Okay, now we are going to discuss about classification of organic compound. Okay, classification of organic compound. Okay, so first, broadly we can divide it organic compound into two parts broadly. Okay, first part is acyclic, and the next part is cyclic. Overall division, acyclic means not cyclic and cyclic means cyclic, so simple. Or you can say acyclic means open chain. Okay, there is no closing of the chain, but here it is closed chain, or you can say ring. Now we can divide this cyclic compound into two form or two part. Okay, first part is homocyclic. What? First part is homocyclic. And the next part is heterocyclic. Next part is heterocyclic. Now let us see homocyclic. We can also divide it homocyclic into again two part. This is very important to know about different kind of compound, the structure of different compound. Okay, how to distinguish them. So let us see, it is alicyclic, very interesting. You just look at it, it is alicyclic. the pronunciation of acyclic and alicyclic seems to be same, but it is not the right case. Here it is acyclic, I mean it is not cyclic, and alicyclic, it is actually aliphatic cycle. Okay, it is what, not aromatic, it is aliphatic cycle. You know, for aromatic compound, it should follow 4n plus 2 Huckel number of electron, it should be planar, it should be cyclic, and generally there should be delocalization in the ring. So homocyclic can be divided into alicyclic, and the next part is aromatic, very important part, aromatic. Okay, we'll discuss broadly about this part later. Now we can again divided this aromatic compound into two part, main important part. One is benzenoid. Okay, benzenoid, are you getting? That means there should be benzene, sorry, benzenoid, and definitely another part will be non-benzenoid. That means in benzenoid the benzene ring should be there. Simple, in benzenoid compound the benzene ring should be there in the compound, and in non-benzenoid, what, in non-benzenoid benzene ring will be not there, but it should be aromatic because it is a part of aromatic classification, so it should be aromatic, but benzene will be not there. Okay, and in the ring there should not be any heteroatom. Okay, there should not be any heteroatom. As for example, non-benzenoid structure, this compound is non-benzenoid. I will discuss about it later clearly, so due to lack of space I am not discussing it here. And in case of heterocyclic compound, what happen, it is not aromatic first of all, so here, so in case of heterocyclic there should be heteroatom. Okay, there should be heteroatom, so here it is furan. Okay, it is furan, so oxygen atom is present there, so it is not carbon or it is hydrogen, it is heteroatom, oxygen, nitrogen, sulfur, this kind of compound. If element if present in the ring in consists of carbon and hydrogen, then it is known as heterocyclic compound. And in homocyclic compound, let us take example alicyclic. Okay, alicyclic example, you can say this compound as a alicyclic compound because it is aliphatic and it is not aromatic, that is why it is aliphatic, and it is cyclic, I mean there is no conjugation here. Okay, and in alicyclic compound also heteroatom may present, so this compound is what, a cyclic compound, and here an heteroatom present, then also it will be a alicyclic compound because there is no aromaticity present here. Clear? So very simple. So in benzenoid compound there may be another element also present here. Suppose in benzene NH2 group may present, but still there is benzene ring, so it will be considered as a benzenoid compound. Okay, here also another benzene ring may be attached here. Okay, then also it will be a benzenoid compound. Clear? But in case of non-benzenoid, due to lack of space I am not drawing it, but non-benzenoid means here there should not be heteroatom in the ring, but it should follow aromatic characteristics. It should be 4n, there should be 4n plus 2 pi electron, and there should be delocalization, and it should be planar and cyclic. Clear? But if heteroatom present, it should not be in the ring, but it should be like this. Suppose it is a non-benzenoid compound, so if the heteroatom present, or attached to the ring with a double bond or single bond, then you can say it should be definitely double bond, then you can say it is non-benzenoid compound. Okay, now we are going to discuss about nomenclature of organic compound. Okay, and there are two types of nomenclature. First one is common name, okay, and the next one is IUPAC name. First one is common name and next one is IUPAC name. Now, what is the difference between these two naming? Common name means generally people used to give name to different kind of thing, substance or compound. Before, in historical time, based on their origin, other criteria, etc. So in this way, this common name used to come first. Suppose acetic acid, okay, as for example, let us take acetic acid, CH3COOH. It is generally ethanoic acid. Its IUPAC name is ethanoic acid, but based on its origin and criteria, other criteria, it is first named as acetic acid. Okay, and what's about IUPAC name? It is actually scientific way or a systematic way of naming or nomenclature for organic compound. It is actually its full form, International Union of Pure and Applied Chemistry. Okay, International Union of Pure and Applied Chemistry. So in this system, I mean in IUPAC system, first of all, what we have to know about the parent hydrocarbon, okay, and functional group and branch chain. Okay, we have to find them at first. Okay, I will take some example, and looking at that example we will try to understand different kind of rule given for this system. Okay, if we take the example and then understand, then it will be definitely easier for us. Okay, let us take an example. In this example, you can see clearly that here the longest chain will be this one: 1 2 3 4 5 6. So it is the parent chain. Okay, now we'll see the functional group and the substituent. Definitely here this bromine and hydroxyl, these two group are functional group, and these are the substituent, alkyl substituent. Okay, or you can say branch. So if the substituent are composed of carbon and hydrogen, then they are known as branch, and if bromine, hydroxyl, aldehyde, carboxylic group are present, we will discuss about it clearly. Just let us understand the main aim. Okay, we have to understand, or we have to find out the functional group. First we have to find out the longest chain, then the functional group, and what the substituent, I mean the branch. Now let us know how to name the alkyl substituent. If it comes from methane, okay, then this group will come, and if it is attached to the main chain or the parent chain, then it is known as methyl group. And if from propane, this group comes, if this group is attached to the parent chain, then it is known as isopropyl group. Okay, isopropyl group. This is coming from propane, and if come from butane, okay, N-butane, then there are many option. Okay, first let us see if this compound comes out. If this compound comes, or this compound is observed as a branch in the parent chain, then how to name this compound or name this part substituent. So it is, there are 4 carbons, so it is coming from butane, and this group is known as secondary butyl group. Okay, secondary 2 carbon attached to this carbon, and here it is the substituent in the parent chain, so it is known as, this is suppose parent chain, so this will be what, secondary butyl. Now again isobutyl group will come and tertiary butyl group will come. Okay, so let us do the draw the isobutyl group. CH3, CH3, again CH2, so this will be isobutyl group, 4 carbon, so butane, and if the structure is like this, then it will be known as isobutyl. Now let us draw the tertiary butyl. So in tertiary, you know, there are 4 carbon butane and 3 carbon should be attached to the parent carbon CH3. So this group if attached to the parent chain, then this is known as tertiary butyl. So this group is isopropyl, coming from propane, if and from butane, one option is secondary butyl and isobutyl and tertiary butyl. Clear? Now by looking at this example, we will try to understand first 3 rule. The first one is longest chain, carbon chain in the molecule is identified. So the longest chain here will be 1 2 3 4, here 5 6, not the longest one, so definitely it will be the longest chain, 4 5 6 7, as 7 carbon present in this chain but only 6 carbon present in this chain, so this will be the what, the parent chain. Okay, this will be the parent chain. Now we have to according to the second rule, we have to see the branch carbon atom. Okay, the branch carbon atom get the lowest possible number. Here if we count the numbering from here, we can also count it from here, or we can also count it from here, 1 2 3 4 s. So in which direction we should count, let us see. So we should follow that direction where the branch chain comes first. Here the methyl comes in the number 3, but if you start from here, then the ethyl will come at number 4. So from here the branch chain comes at number 3, but from here the branch chain comes at number 4. So we should follow this direction as it comes in the number 3. Okay, clear? The second rule is clear. Now we are going to see the third rule. According to third rule, alphabetical order should be maintained. So CH3 means what? I have already discussed. That means methyl, and C2H5 means ethyl. So according to alphabet, E come first, then M comes. So definitely we will in the naming process we should write first ethyl. Okay, after that we should write methyl. So how to write this? Very simple. In the number 4 ethyl is there, so alphabetically we should first write ethyl. So it will look like 4 ethyl. This should be written in capital letter, first letter, then 3 methyl, in 3 position methyl group is there, and then as there are 7 carbon present in this chain, so we should write as heptane. Okay, so the compound is 4-ethyl 3-methyl heptane. Clear? Simple. Now we will take another example, then discuss the next rule. Now the next rule. Okay, so if here the same position, 1 2 3 from the left side, and from here 1 2 3. If in the same position, position 3, okay, from both direction, 1 2 3 1 2 3, if two branches present, here methyl and here ethyl, then which direction should we follow? So here we will follow that direction where the alphabetical order is maintained. So it is what? Methyl group, and this is ethyl group. So alphabetically which letter come first, we should follow that direction. So definitely it is ethyl, so it will come first. So 1 2 3, this direction should be followed. I mean, we should follow that direction where the alphabetically the letter which come first should be followed. Now if here in presence of in place of ethyl, methyl group present, then what happen? If it is methyl, okay, in not ethyl but methyl group is present here, then we have to name it like what? From here it is 1 2 3 4 5 6 7. Okay, so we should write here 3,5 dimethyl. Okay, then the name will be 3,5. So I am writing this because it may make us confuse that how to write if same alkyl group present in different position. So then we should write di, tri, etc. So here it will be 3,5 dimethyl. Very simple. 1 2 3 4 5 6 7, have 10. Okay, so now we have understood the fourth and fifth rule. Okay, the first rule is the fourth rule is that if two and more same substituent present like methyl and methyl, then it should be written as di or tri, and the number should be given before 3 5 dimethyl. And the fifth rule is if same, in case of ethyl and methyl, if same position two different alkyl group present, then we should start our numbering from that direction where the alphabetically first letter come. Okay, so here E alphabetically it comes first, so numbering should be start from that direction. Now we will discuss about cyclic compound. Okay, now I'll discuss about cyclic compound. Cyclic, let us take an example. Okay, this compound here, it is a 5-membered cyclic ring is there, so it is cyclopentane, and here two substituents are there, two branches are there. This is methyl and this is propyl. So where to start the numbering, from here or from here? So definitely we should start our numbering from the branch carbon. So this number and this carbon should be considered as either this is as a 1 or this is as a 1, but we should consider that carbon as number 1 where the alphabetically the first letter come or smaller letter come. So here it is what? Methyl group, and it is propyl group. So in between methyl and propyl, definitely methyl come first, so we will consider this as a number 1, and this is 2 and this is 3. We will not consider this numbering 1 2 3 4, because if we consider this root or this root, then it will come in number 4, but it should come, the next branch chain should come very first. Okay, so this actually nomenclature follow first root. Okay, so 1 2 3, so it will be what? 1 methyl, let us write the name 1 methyl and 3 propyl what cyclo. Here we should write cyclo pentane. Clear? Okay. Now I will discuss about some problem in given in the exercises, and I'll discuss in preference. I'll discuss about those problem which I have already covered, and step by step we will discuss about other problem or other exercises in the later classes. So please subscribe and follow this channel for latest update or latest class. Now uh, in the exercise it is given that which one is correct. Okay, some example are given and which one is correct you should find out. So one is given, one problem is 2,2 dimethyl pentane, this one is correct, or 2 dimethyl pentane, this one is correct. It is very simple. For that you just write the what you have to write the parent chain. Pentane means 5 carbon, so 5 carbon. Okay, so 2 dimethyl, so in 2 position 1 methyl and 2 position another methyl, so 2 dimethyl pentane. So this compound you can understand it very easily. CH2 CH2 CH3. So here the correct one will be 2 dimethyl pentane, because here there are two carbon present here, 2 methyl present here, so you cannot say that it is only 1 methyl. See, if 1 methyl group will be present here, then it will be definitely 2 methyl, but here 2 dimethyl pentane, this is the correct answer, because 1 2 3 4 5. Okay, here in 2 position there are 2 methyl, so 2 methyl means we have to write 2 times with a comma, so 2 dimethyl pentane. Clear? First problem solved. Now the next problem is 2 next problem is 2,4,7 trimethyl octane, trimethyl octane or 2,5,7 trimethyl octane. Which one is correct? I have already told we have to write first what the skeleton, I mean the parent chain. So here octane 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 8 carbon atoms should be there, and 2 position 1 methyl. Okay, 4 position 1 methyl, and in 7 position 1 1 2 3 4 5 6 7 8, in 7 position another methyl. Okay, that is very simple. So 2 1 2 3 4 5 6 7, so 2 4 7 trimethyl octane, this is correct answer, because if you consider this one 2 5 7, then definitely 2 5 7, here the methyl should be in this position. Okay, the methyl should be in this position if we follow this road. Then if we follow this road, then we have to start it from this side, because this branch will come first, so here we have to start from this side. 1 2 3 4 5 6 7 8, then this 2,5,7 trimethyl octane is not correct one, because this methyl should this carbon should take or given that number where the lowest number should be given here. Okay, this methyl should be given the lowest number, but here if we write 5, then from right side if you follow the numbering, then it will come into 4. Again the correct structure, the name of the correct structure will be this one, 2,4,7 trimethyl octane. Okay, Now the last problem is 2 chloro 4 methyl pentane. So again we have to write first what? The skeleton. Carbon, 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 carbon. Carbon, pentane means 5 carbon. Now 2 into position chloro and 4 position methyl. So either it is 2 chloro 4 methyl pentane or 4 chloro 2 methyl pentane. That means which one is correct? Okay, so here the functional group should comes first. We will discuss it later, but just remember this is chlorine is functional group and here methyl is just a substituent, so the functional group should come first. So definitely it should be 2 chloro. Okay, the number should not start from this side because the functional group should take or get the lowest number. So it is 2 chloro 4 methyl pentane will be the correct answer. Okay, today we are concluding here, but we will discuss about this chapter continuously, so just follow and subscribe this channel.